Hello everyone, this is Team 16 and welcome to our operating system virtual lab. So I'll be giving you a brief explanation of what an operating system is. So it's basically a software that manages the computer hardware, and this hardware must provide appropriate mechanisms to ensure the correct operation of the computer system and to provide user programs from interfering with the proper operation of the system. So here, this is the main home page where we have provided several buttons. When we click to About, we'll be shifted to another part of the page where we have operating system components and a brief explanation of the same. We can come to this page by clicking Find Out More also. So the six operating system components are file management, process management, input-output device management, network management, secondary storage management, and security management. So here is a brief explanation of all of the operating system. So an operating system is broadly classified into four different algorithms. And to know more about those algorithms, we can click algorithms, or we can also click view demo to go to the same. So here are the four algorithms. So process scheduling and deadlock and concurrency have been described and worked on by our other classmates, and page replacement has been described and worked on by our senior groups. Uh, our team has focused on disk scheduling algorithm. So digging deeper into the same, I'll be providing you some more information about what a disk scheduling algorithm is. So here we'll be shifted to another sub home page where we have a brief description of disk scheduling. Here we have several buttons. When we click information, we'll be shifted to this page. We can also go to this page by clicking for more information. So here we have a diagram where diagram of a disk scheduling simulator. So this is track T. This is a part which is known as spindle, which has the ability to rotate. This section is known as sector S. This cylindrical part is known as cylindrical C. This is known as platter. This is known as an arm, and this is a read-write head. This whole part is known as an arm assembly, which has the ability for to and fro motion. Okay, so a quick description. Multiple input-output requests may arrive by different processes, and only one input-output request can be served at the time by the disk controller. Thus, other input-output requests need to wait in the waiting queue and need to be scheduled. So, for demonstration, we can click to this, or we can click to algorithms to know more about the six algorithms under disk scheduling. So all the six algorithms are mentioned here. The first one is FCFS algorithm. For more information, we can click here. FCFS stands for first come first serve. So this is the brief description of the same. We have some advantages and disadvantages mentioned here. We can click visualization to have a quick demonstration of this algorithm. We can go to this page also by clicking demo. So this is an input function where we have the current track position, and the track series of track numbers have to be mentioned here. When we click submit, we'll be getting the inputs, we'll be getting the output of all the mentioned inputs, and we can click calculate for the seed time. And when we click show graph, we'll be getting a graph of according to the mentioned inputs. So we can take an example, taking 50 as a current track position and the random track numbers here. When we click submit, we'll get an output. When we click calculate, the total seek time will be calculated here. When we click show graph, we'll be getting a graph of an FCFS algorithm. We have also added a function here where we can download the graph in any of the format. So this is the FCFS algorithm. When we go back, we have another algorithm which is known as SCAN. It is also known as an elevator algorithm. When we click more information, here is the brief description of SCAN algorithm. some advantages and disadvantages. Clicking visualization, we'll be shifted to another part of the page where we have the demonstration. Taking the same track position to avoid confusion. Here we have one more option of adding the direction. So we'll be adding left or any of the direction you want for mentioning the graph. So here this is submit, calculate, we'll be getting the total seek time here. Show graph, wherein we'll be getting the graph of the algorithm here. We can also take right, just for an example. This is the graph from right. Okay, so going back, this is the third algorithm, which is look, the advanced version of scan algorithm. So clicking more information, we have the brief description of what a look algorithm is and several advantages and disadvantages. For demonstration, we'll be going to the visualization part. Okay, so same track position, same track number, and any random direction. We'll be clicking submit for the track position here, calculating the total seek time and the graph. Well, now going to the algorithms. Now the fourth algorithm is SSTF, which stands for shortest seek time first. Clicking more information, we'll be getting a brief description of the same. Advantages and disadvantages of SSTF algorithm is mentioned here. Clicking visualization, the same thing, submit, calculate, and show graph. Here is the graph of seek time. Okay. Now, the fifth algorithm, which is C-scan. C-scan stands for Circular Scan Algorithm. For more information, we'll be having a brief description of the algorithm, several advantages and disadvantages. For visualization, we have the same inputs and taking left as the direction. Submit, calculate the total seek time and show graph. The graph is here. Okay. So now the sixth algorithm, CLOOK, which stands for Circular Look Algorithm. For more information, here we have the brief description as mentioned earlier, the advantages and disadvantages of the same. Visualization, the track position, the track number, and the direction. Submitting, calculate, and this is the graph of CLOOK algorithm. Okay, so here we come to an end of the description of all the six algorithms. Now we have added one more function where we have compared all the six algorithms. So when we click more information, we have the description of seek time and response time and all the six algorithms again. Here, when we go down the page, we'll be getting some input functions. So here the track numbers have to be less than 200. The same to we are adding the same values so that we can avoid confusion. When we show the graph, we'll be getting the graph. So this is the comparison of seek time of all the six algorithms. Okay, so this is the end of our discussion, and here this was our project. So the last thing I would like to describe is this is the home button where we can go to the disk schedule algorithm simulator, and this button will help us to go to the main home page, which is the operating system virtual lab. Okay, so thank you so much for watching.